Good morning, everyone. Welcome again. My name is Henry with the Tutoring Business A STEM Tutoring. Today, you might see in this photo, there's a photo of a simple AA battery and a foil bubblegum wrapper. What does this have to do with electrical current and what we're talking about today? Well, let me explain. So, first of all, we're going to talk about Ohm's law and then electrical power output. All students in basic physics and also in basic electrical engineering courses learn about Ohm's law, that V equals IR, where V is voltage or the electrical pressure, the potential for current to flow. I is the electrical current, how much current actually flows. Voltage is measured in units of volts. Current is measured in units of amps. And then resistance, R, is measured in units of ohms, symbolized by the Greek letter omega. So the voltage equals current times resistance. So for a given current, a higher resistance requires that you apply more voltage. Now, power equals voltage times current. The potential, the pressure, times the amount of flow, which kind of makes sense. Power is measured in watts. Using this equation V equals IR, we can solve for I by dividing both sides by R. So we get V over R equals I. If I substitute this in here for I, then I get V times V over R, or V squared over R. So what is the implication of this? For a given voltage, if you lower the resistance in the circuit, you will get higher power output. So let me show you a simple circuit. Here's a battery, plus and minus terminals, and a resistor. Let's say the battery is 1.5 volts, which is typical for AA batteries and AAA batteries, also C cells and D cells. And let's say we have a 1 kilo ohm resistor, 1000 ohms. And we want to find the current, I, flowing in this circuit. So, using V equals IR, we can use this formula. Current is voltage divided by resistance. So, 1.5 volts over 1000 ohms, because 1 kilo ohm is 1000 ohms, gives us 0.0015 amps. Oops. Let me see if I can write this correctly here. And that is also equivalent to 1.5 milliamps, where there are 1000 milliamps in a full amp. So that's a small amount of current. And again, if we lowered the resistance, the amount of current flowing would increase, as would the power dissipation. So if you have a fixed voltage source, which most batteries are, for example, a AA battery, your car battery is 12 volts, a 9-volt battery obviously supplies 9 volts, things like that. If you have a fixed voltage source, then a lower resistance in the circuit gives you more current flow and also more power flowing through the circuit. So how can we use this knowledge to our advantage to have a simple fire starting method? Let's go back to the image here. If you have a AA battery, a 1.5 volt battery, and let's say you have a foil gum wrapper or a foil candy wrapper. Usually those foil gum wrappers, it's paper on one side and foil on the other side. Well, foil is metallic, which means it conducts electricity. It provides a low resistance path for electricity. So what you could do is take a AA battery and your foil gum wrapper, connect it across the terminals of the AA battery so that current flows. Because there's a lot of current flowing, because there's a lot of power dissipation, the foil heats up. The paper side will ignite, and now you have a simple way to start a fire if you happen to have a AA battery from, say, the flashlight you carry in your pocket, and maybe a foil gum wrapper from the piece of chewing gum you just started chewing a few minutes ago, and you need to start a fire because you're out in the woods somewhere. So here's how that would work, right? Let me clear some of this off. So how would that work in practice? I don't have a good photo, so I'll draw a diagram to show you all that. So you have your AA battery. This is normally the plus terminal, and this is the minus terminal. And you take the foil wrapper and connect it between the two terminals. The foil side needs to be touching the terminals so that it will conduct electricity. The paper is on the outside. As current flows, because this is a low resistance path, power dissipation is very high. The only way for this piece of foil gum wrapper to dissipate the power is by heating up. It heats up, the paper ignites, and now you've got a simple way to start a fire if you just have some random flotsam in your pockets, like a flashlight with a AA battery, or any battery would work, and a foil gum wrapper or foil candy wrapper. So there is a usefulness to understanding basic electronics and how basic electricity works if you're ever in a wilderness survival situation. So I hope you enjoyed this lesson. I hope it makes Ohm's law and power dissipation a little more clear to you. If you'd like to learn more, I'm available for hire as a private tutor. The first 1-hour lesson is free for all new students. Try before you buy. You take no risk. The burden of proof is entirely on me to demonstrate outstanding service and value in helping you succeed. And as a thank you for listening all the way to the end of today's video, if you mention the code FREEBOOK when you contact me at our first in-person tutoring session, the free lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote this book in an effort to help students, in particular college students and high school students, succeed in school, in work, and in life. Thanks for watching. Have a good day.